So this moves us into chapter 11, powers and polynomials. Again, a power is another word for exponent math. So if I give you 3 to the power of 2, a lot of times we say that's 3 squared. 3 squared means 3 times 3, or we would write that as 9. 2 to the power of 3, a lot of times we say that's 2 cubed. 2 cubed would be 2 times 2 times 2. So this 2 or this 3 here, this is called an exponent, or also we call that a power. So 2 cubed, that would be 2 times 2 would be 4, 4 times 2 would be then 8. So look in our examples, we're using variables. So if I have x to the third power, x to the third power would mean x times x times x. So exponents are quick ways to express algebraic expressions that involve multiplication. So if I have x squared, notice x squared would be the same thing as x times x. So the power of 2 means there's two x's connected by multiplication. X to the power 1 would just mean the same thing as x. So notice how x is actually the simplified version of this. So MyLab does not like x to the power of 1. X to the power of 1 is simply x. So when you get into just having the variable x, notice that there are a couple of things about the variable x. The variable x has a hidden coefficient of 1. It also has a hidden exponent of 1. So that's really just written as simply x. So not only is its coefficient hidden, but its power is hidden. Now also there's a unique exponent x to the 0. So x to 0, notice how really there's a coefficient of 1. 1x to 0 just means there's no x's, just the 1. So what we learn is anything raised to the 0 power is equal to 1. So 0 is actually a special exponent. It's kind of special. It's kind of different. So you almost have to put that into memory. There's really no mathematical calculations involved. Anything to the 0 power is 1. Now, some other things we need to pick up on is the word term. A term is going to be a number, variable, or product of a number and a variable. So a single term is called a monomial. So for instance, x to the fifth would be a monomial. So would x to the sixth be a monomial. So notice how here, since they're connected by multiplication, we want to multiply this monomial times this monomial. So remember, x to the fifth really means there's 5 x's connected by multiplication. So 1, 2, 3, 4, 5 x's connected by multiplication. Times then x to the sixth, which means there's 6 x's connected by multiplication. So in other words, if we simplify this, how many x's are connected by multiplication? Well, there's 5 here, and there's 6 here. So notice that really what we're doing is adding this all together. So I can write this as x to the power of 11. So x to the 11th power. So x to the 11th power means there are 11 x's present. So if you have x to the 5th times x to the 6th, there's a rule. If you have something, a lot of times the rule looks like this. If you have a raised to the nth power times then a raised to the nth power, so if you have a monomial that has the same base, all you really got to do is keep that base and add the exponents m plus n. So notice how if we have x to the fifth, and again, parentheses imply multiplication, times then this x to the sixth, notice that our bases are the same. So all I have to really do is keep the base and add the exponents of 5 plus 6, and that ends up being then x to the 11th power. That's kind of the shortcut, is there's a rule. So if you're multiplying with same bases, the shortcut is you actually can add the exponents. So I don't really have to expand it out, but you can kind of see that's what it means. There's 5 x's present, there's 6 x's present, therefore there are 11 presents, 11 x's present, but they're all connected by multiplication. That's the thing about an exponent, is everything is related by multiplication.